Welcome. Welcome to the new Teacher Law class series, which is Survey of Mathematics or Survey of Maths. And today we'll be discussing about Chapter 2, Set Theory. And I have prepared a set theory notes, and it is free, and you can just download it from my description box. Click on the link and download it, and you can follow what I'm doing here too. It will be exact the same file that I will be using and what you are using. Okay? And set theory. Basically, I have divided this set theory into two parts. This is part 1, basic set concept, and part 2 will be survey problems. And basically, this topic is adapted from the book Thinking Mathematically and the chapter 2. And actually, the whole thing is the same, but I just kind of modified it so that I can explain it more clearly and in procedure. And so you can look at the menu page. This is the table of content. All of these actually are under basic set concepts. And once we learn all of this, then we go to survey problems, which is what the exam will become out. These are all the foundation that builds up for you to answer in the exam. Remember, part 2 is the real exam part. Okay, this one will be in your midterm or in your final for sure. Okay, depending whether your teacher want to include it in final or not. Okay, just a quick reminder that this set theory will have a lot of sign, this signs. So remember that it is important to be careful with all signs in mathematics, and especially also in our lives too. So first, part 1, the first thing we'll be learning is methods for representing set. So basically, when you look at the word set, you'll be confusing or thinking, what is set? Basically, you just imagine that set actually is a box. Yes, this is a box. And you're thinking, this box, what is inside the box? This is what we'll be discussing now. Methods for representing set. That means that now I want to explain about this box. So what are the ways that I can explain that what is this box? Or actually set in this case. So the first way is that word description. I just explain and describe what is this. Or the second way, roster method. I will be listing what is inside the box. And the third way, set builder notation, which is kindly a little bit different and it's kind of special from what we are learning. So, example, this is a box. Examples that I put, let me erase it. Okay, so I try to put 3 marbles inside this box. Okay, no, let me change it. I try to put a red color marbles. I try to put blue color marbles. I try to put a green color marbles. And now, word description. If I want to describe what is this, I will say that this box have 3 color marbles. Have 3 marbles. That's all. But for roster method, I will try to explain that box inside have red, blue, green color marbles. I will explain in details. I will list down what is the marbles, the color of the marbles inside the box. And in set builder notation, just like word description, I will just explain that saying that there's a box and there's marbles inside. And that's all. Okay? So this is the difference between word description, roster methods, and set builder notation. These are the 3 ways that to represent the set, or in simple ways explain what is inside the box. So you can look at the first example here. Here says that set B. Don't mind with the B because it can be anything. It just put the example B here. Set B is a set of days in a week. Okay, it just explained that the box have the days of a week in a week. So you know that what's the days in a week? We know that is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Word description is kind of lazy. It doesn't want to explain our listing down. But roster method, just like the roller coaster you go when you sit when you go to the playground, it have listing down 1, 2, 3, 4, all the peoples inside. One here, one here, one here, 1, 2, 3, 4, 5, 6, 6, 4. So roster method explain and listing down everything here. Okay, you say set of the days in a week. Okay, it is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So roster method, just like roller coaster, it listing down all the members here. Okay, set builder notation is similar to word description, but it's also kind of similar to roster method in the way of writing. Okay, set builder notation similar in the way of writing. You see here, you see here. There's a column here, column here, column open here, column open here, but it is similar when it like word description when it explains in this way. It doesn't list down at all. Okay. In formatting is similar to roster method, but in the way of writing is similar to word description. So kind of combined. Okay. But you need to remember that it put X line and the X. Okay, it's kind of different, but it's kind of same also. Okay, we'll try this one. Look at the second example. Here says set P is a set of the first 5 presidents of the United States. So as usual, this is a box, and this box says that okay, it is a set. This is a box. They have 5 presidents of the United States. One here, 3, 4, 5. It doesn't list down that who are those presidents. But in roster methods, it explains that the first, the second, the third, the fourth, the fifth, and all are listed here. 1, 2, 3, 4, 5. Set builder notation, just like the previous one, the formatting is kind of the same, but it is like roster method. No, it is like word description. It lists down only first 5 president, first 5 president. Okay. So now let's try with some exercises here. So now the questions give us that the set builder notation, but we need to write down the word description and the roster method. Okay, let's look at here. A is equal to column X or line X is a month that begins with the letter M. So word description, we are lazy, we doesn't want to list it down. We will just say that, okay, just try to copy a little bit. Set A, because this is set A, right? A is the set of, and here says what? Month that begins with the letter M. So we'll continue. Set of months that begins with the letter M. And that's all. This is what we can do and what we need to do for word description. And how about roster method? Roster method means that we need to list it down. Okay, we were using the format here. It will be A is equal to column, then what? Then we will list down. So what is the month that begins with the letter M? So let's start counting. January, February, March. Oh, March. So we write down here. March. Then continue. April, May. Oh, May. June, July, August, September, October, November, December. Oh, so that's all. 2. So we'll close column. So that's all for roster method. So let's look at the next one. Next exercise. So L is equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So you can look at this A to Z. All letters are here. All alphabet are here. So we can know that this is talking about the alphabet in English. So here we can say set. Look at here. This is what? This is L. So this is set L is the set of these are all alphabet in English, right? So we put alphabet in English. So that's all for word description. And for set builder notation, be similar thing. We put an L here equal to column X, line X is, then we'll copy here, the set of alphabet in English. That's all. But if you want to make it more clear, actually you can read out this one. X is the alphabet in English. That's all. Without no need, the set of also can. Okay. So that's the ways of representing set. Remember, we have three ways. First is using word description. Second, using roster method, listing down. And we have the last one, set builder notation, which is kind of the combination of both. Okay. That's three ways. And now, let's continue. Empty set, which is the next topic we will discuss. So empty set. So what's empty set? Just now we talked that we can try to imagine that set actually is a box. So empty set, basically you can just say that it's an empty box. There's nothing inside. So, and here says empty set is a null set, and it says a set that contains no elements. It means that in the box there's nothing inside the box. So, and there's also a sign or a ways of writing it, which is using two column without anything inside, or another one is just a circle with a slash. So let's practice this one, or also this one. Okay, so let's look at the example. It says that this is a set builder notation, right? This is what we learned. So it says that this is explaining what is set, explaining the representing set. So x is a number greater than 10 and less than 5. So, okay, there is a number that is greater than 10 at the same time and less than 5. So, is there a number that greater than 10 at the same time less than 5? I don't think so, right? Example, the number that more than 10, it will be 11, 12, 13, and more. And the number that less than 5, it will be 4, 3, 2, 1, and more. So it doesn't have any number that happens satisfy these two things together. It means that no, we don't have. That's why the set here actually is empty, because it doesn't have a number that is greater than 10 at the same time lesser than 5. Okay, does it make sense? Okay, so I hope you get the idea that this is the idea. Okay, so example, you can say that X is a person with skin of green color. So in real life, okay? So basically X should be an empty set. Why? Because it doesn't have a person with a green color skin. Of course, I don't say hug. Okay, hug is, hug is not in real life, okay? So let's look at the second example. Say it says that here X is a font that speaks. Fawn is basically a little deer, small deer. It says that, or basically it's an animal. So can animal speaks? Oh, no, right? That's why no means that's why this is also an empty set. Okay, so I hope you understand, and let's continue the exercises so that we can strengthen our understanding on this empty set. So here says, which one of the following of the empty set? So which one is empty set? Okay, let's look at here. The first one, a column and a column, but with inside there's a zero here. So is this an empty set? Give you 3 seconds and think. 3, 2, 1. The answer here is no, no, no. Why? Why no? Remember, the sign that represent empty set is only these two. If you put a zero inside, it means that zero is one of the element, or which means that if you have a box, actually we have a zero inside the box. Only this and this represent empty set. Okay, now let's look at the second questions. Column and another column. So is this empty set? 2 seconds. 2, 1. The answer is yes. Of course, this is exactly the same thing as this one. Okay, so let's look at the next one. There's a column and also another symbol here. So it means that empty of the empty. Wow, this person is so empty. Okay, so is this an empty set? What do you think? Give you 3 seconds to think. 3, 2, 1. The answer is no. Why? Because this means that this symbol is one of the element in the set. It means that if there's a box, it means that this symbol is one of the elements inside the box. Okay, so don't confuse with this one. Okay, so let's look at the next one. X is a number less than 4 or greater than 10, or greater than 10. So is it okay? X is a number less than 4 or greater than 10. Give you 3 seconds and think about it. 3, 2, 1. The answer is this is no. This is not an empty set, which means that this equation or this set actually has elements inside. Why? Just now, you might ask, why? Just now we may look at the example upstairs. It says that it is impossible to have a number that is less than 4 and at the same time greater than 10. Right? Just like this question. Greater than 10 and less than 5 is impossible, right? However, just now it used and. That means it should satisfy both of the situation. But here, this question use or. It means that it can be either less than 4, it can be either greater than 10. So which means that the elements inside, let me write in the roster method here. It will be x is equal to, it can be what? It can be 1, it can be 2, it can be 3, it can be 11, it can be 12, it can be 13, and more. Because it says or, it means that either one is okay. So which means that you can understand as this one or this one. So of course, we can have less than 4, of course we can have greater than 10. If it says and, it means that you need to have a number that satisfies both of the situations. Okay? I hope you understand. And the next one, x is a square with exactly 3 sides. Square with exactly 3 sides. So try to think about it. 3 seconds. Is it an empty set or no? 3, 2, 1. The answer is yes, it is an empty set. Why? Because square means like this, right? Okay, so square must have 4 sides, and this a square with exactly 3 sides. We doesn't have something like this. That means it is an empty set. Okay, I hope you understand this one. And let's go to the next one, next subtopics. So here says that notations for set membership. So basically, there's another 2 sign. Just now we learned. Just now we learned about this sign, and we also learned about this sign. And both of these actually tells you that these are empty set. And now we have another one saying that membership, set memberships. Actually, we call this as notation. Okay, we also call it, sometimes I call it sign, but it's okay. The formal way of reading it is notation. So you need to understand. Now we have learning 2 more. One is like this. Another one is like this. Okay. So let's see, what does that mean? So this one means that an object is an element of a set. So this basically means that is an element of. But the one with the slash, it says that is not an element of a set. Is an element of a set, is not an element of a set. So for example, there's a box. Okay, you can see here. I put here a number 1 here, a number 2 here. Let me ask you, is 1 the element of the box? The answer is yes, because you can see it here, right? The 1 is here. So we use the sign of the notation of this one. Okay. Then I ask you, is 3 the element of the box? You say, no, I didn't see 3 inside. So the answer is no. So we use the notation of this one. Is it simple? Yeah. So let's look at the questions. How the questions will be like. So here says that determine whether each statement is true or false. Okay, basically it uses the notation and you will see whether it use it correctly or not. Okay, so let's look at the questions. Here says R is an element of this one. So is R part of, or is an R is an element of this A, B, C, D, E to Z? Is it true or false? The answer is true. And I know you will ask, hey, why? Why? Just now you say, okay, when there's 1 inside this one, then it's okay because there's 1 inside. But R is not inside here. I didn't see R here. But actually, it's just a shortcut, you know. Math is lazy. When we put A, B, C, D, E, when we put dot, 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 and we put Z, we assume that you must know that in this set, it includes A, B, C, D, E, F, G, H, I, J, K, L, M, N until Z, which R is included inside. Okay? So dot, dot, dot here actually means everything. F, G, H, I, J, K, L. That's all. And I know sometimes you're confused. What if I'm not sure? So example, if I put 1, 2, 3, dot, 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 7. So can you guess what's in between 1, 3 to 7? The answer is 4, 5, 6. Yeah, 4, 5, 6. That's all. So if I put here 4 is an element of this set. Is it correct? The answer is yes. Because we should know that 4 is in between 3 to 7. However, if I come up with this question, 1, 3, 5, 7, 9, dot, 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 21. Then I ask you, is is 10 an element of this one? 10 is an element of this set. Is it true or false? What's your answer? Your answer should be false. And you will ask, why? 10 it should be in between 9 and 21, right? However, you need to look at the patterns of the numbers. So if you can see, it skip the even number. So 1, 3, 5, 7, 9. So you must assume that it will be 11, 13, 15, 17, 19, and 21. So you should know that 10 is an even number and it shouldn't be part of this set. Okay? So I know it's kind of weird, but math is lazy. So what can we do? So let's look at the second question. 7 is not an element of this set. 1, 2, 3, 4, 5. Is it true or no? The answer is true. Why? Because it's start from 1, instead from 5. That's all. It doesn't put a dot there to represent it continues. Okay. So let's look at the C. So C says column A equal to column A, comma B. So actually this supposed to be this sign. Okay. Sorry for the mistake. So A is an element of A, comma B. So is it true or no? So I will give you 10 seconds to think this for this one. Okay, 10 seconds. The answer is false. I know you will ask me, hey, why is false? We have A inside, right? Let me ask you. Okay, this is the box. Okay, I will say A is here, B is here, and I say A is this one. So I say A is an element of A. Is that correct? The answer is yes. But if I put in this way, A, B, I put here A. Is A an element of this box? The answer is no. Why? Because it should have a circle inside. Just like this case. You cannot say that this is inside because this is only A, but this is the whole thing. So in order to make this one, this whole, should I call it equation? No. Should this thing to be true, it should be A is part of the element of A, B. Okay, so you can see that it is so strict that the whole thing should be inside to say that yes, it is an element of that set. Okay, so that is so strict. Okay, so be careful. Okay, so I'll be stopping here. So I'll be continuing in the next video for the next page. Okay, so relax for a while, take a rest, and thank you. Goodbye. Be safe.